Hey everybody, welcome back. Today I'm going to show you how to put progress bars in your terminal programs, and also we're going to talk a little bit about why progress bars in general are so bad. Welcome back, folks. I hope life is treating you well. Today I want to talk about progress bars, not because they're particularly challenging or even all that interesting technically, but because they do provide some important lessons that I think every programmer would do well to remember. Before we get into it, source code for this video and others is available through Patreon. Also, I love hearing from you that you enjoy this content. If you are enjoying this content, please like the video, subscribe to the channel. It really helps out. Okay, so about progress bars. Unless you've been living under a rock, you've seen a progress bar. Anytime we're doing anything in software that takes a certain amount of time, so long processing, downloading things, we're going to see a progress bar. And they're pretty much all bad. Well, I mean, not bad. Bad is the wrong word to use. They're inaccurate. They tend to not give you an accurate view of where they are in their process and how much time you have left. They may, for example, tell you you're halfway done and you're almost done, or they may tell you you're halfway done and you have a lot left to do. And it's really funny when people find out what I teach and what I do, this is people outside the field. Often the question that they ask is, hey, what about those progress bars? Why can't you fix that so that they're accurate? And so I thought today it would be fun to do a video about progress bars, and I thought we could just talk about what's going on, but I think it's more my style and more in line with what we do on this channel to dive into code and actually build one and look at what it's like to actually put a progress bar into one of your programs. So I'm going to show you how to make a progress bar for your terminal programs. And through this process, hopefully we'll learn a few things. We'll be able to talk about a few things, and hopefully you'll come out on the other end a better programmer. So let's jump into the code. Okay, so here's a simple starter program. It doesn't really do anything yet. Also, I have a simple makefile over here. It's pretty typical. All it does is compile this program. Now, all I want to do initially for this program to do is to periodically update a status bar. Okay, so a progress bar. So let's start by making a simple loop. In here, what we're going to do is just let's make a for loop. And let's go from 0 to 100. And actually, I want to go all the way to 100. So let's add greater than or equals, and let's increment it. Okay. And then each time through the loop, I want to call a function that's going to update my progress bar. Let's just call it update bar. Okay, update bar. And we'll pass in our I. So basically say we want to update the progress bar with a particular percentage. It's going to be some number between 0 and 100. And then just so we can see what's going on, I'm going to wait a little while. So let's just use usleep or microsleep and sleep. Let's give it 20,000. So that should be 20 milliseconds. It should be enough that we should be able to see what's going on. It should slow things down and we should be able to see things. We can always adjust it later if that's not enough time. Okay, so simple enough. Now we need to, of course, implement this little progress bar function. So let's come up here. And I want to start out by making this as simple as possible. Okay, so we could get fancy. We could add colors. We could use curses to place the progress bar someplace like on the top left or bottom right. We could put it in a fixed location on the screen. Today, I'm not going to really do that. Let me know down in the comments if you'd like to see videos on getting a little more fancy with progress bars. But for today, I'm just assuming that your program is doing something, maybe a long download or something, and we just want to stick a progress bar on the current line that's going to grow until our task is completed. Okay, so first of all, let me just come in here and make a constant or const int, and let's say it's going to be the length of our progress bar. Okay, let's make it 30 characters. I can adjust this to whatever I want, but let's start with 30. And then let's come down here and make our function, our update bar function, bar, not var. I'm going to return void because this just updates the progress bar. It doesn't really do anything. And I'm going to take in a single integer. We'll call it %done. Okay, now in here, really what we're going to do is we need to print out a progress bar. And keep in mind that I could pass in a double, which could be a fraction from 0 to 1. That would work perfectly too. I'm just choosing to work with integers, but feel free to change this according to your own style and your own program, how you want it to work. Okay, so now what I'm going to do here is I need to figure out how many of my 30 characters should be marked as done or filled in. Okay, so let's make a variable called num chars. And what I'm going to do is I'm going to take the percent done. Basically, this is the percentage of the 30 characters that I want to be filled in. And we'll just multiply that by the progress bar length and divide it by 100. So notice I'm multiplying first and dividing because these are integers, and so if I go the other way around, I'm likely to zero stuff out. I'm going to get this floor effect. If I divide everything by 100, it's all going to be 0, and then you multiply that by the progress bar length, and our progress bar isn't going to grow. Okay, so now we know how many characters we want to print out. Now really simply, all I'm going to do here is let's start off our line with a open square bracket, and then let's go down and let's just make a for loop that is going to, we're going to go for the number of characters here, and I'm going to add an S here just because I keep saying characters, and let's increment I, and then for each of these, all I'm going to do is just print out a pound sign. Okay, so the idea here is that the pound sign is representing how, that a particular part of the progress bar is full or done. You could use whatever character you want. I'm just using the pound sign because it kind of has this square, kind of fills in the space. So it's going to look like a bar. Okay, and then down here, I also need to finish it up. Now we've done the first part of it. So let's make another for loop. And this is for how many non-full entries there are. And so let's just do prog bar length minus num chars. Okay, so this is how many basically we have not finished, and I'm going to make this a space. Again, feel free to change these characters to do whatever you want aesthetically with this progress bar. And then down here, once we're done, what I'm going to do is say printf. Let's close our square bracket. I want to use the square brackets to make it look like a bar. And then let's also just print out the actual percentage. Okay, you see this sometimes. Let's say 50% done, 20% done, whatever. And let's pass in here our percent done. So this is going to close off the end of our progress bar and print out what percentage done we are. Now at this point, we can go ahead, let's come down here, and at this point we should be able to compile our program. Okay, so we can make it and we can run it. And you can see that it does actually fill in the bar as we go up. And of course, right now you're saying, hey, that's not a progress bar. That's just printing out something that looks like a progress bar on a bunch of different lines. Yeah, I know. But I wanted to get this in place first. So now let's go back to our code and we'll make it grow in place. And to make it grow in place is really, really simple. Now I'm going to make a few little changes to my program. The first is I'm going to come down here and I'm going to remove the new line. And then I'm going to come up here and add a carriage return to the very beginning. Okay, now what does this do? The new line tells the computer or the terminal really to jump to a new line after each progress bar. Now we don't want to do that. We want to stay on the same line. Now the carriage return, the whole idea of a carriage return comes from old typewriters and teletype machines, and it literally means return the carriage or the cursor to the start of the line. So now we're saying just jump back to the start of the line, the same line we've been printing on, and we're going to print out things again over the top of our last line. Okay, so once we've done this, now we can come in, we can compile it again, and now if we run it, well, that didn't work so well. Okay, it basically said nothing, and then all of a sudden it said 100%. And the problem here is that standard out is buffered. Okay, so this is for speed reasons, but basically the stuff we print to standard out isn't actually pushed to the screen immediately, and this might behave differently on different machines, different operating systems. But on my machine right now, it's saying, I haven't seen a new line character yet, so I'm guessing that Jacob's still working on the current line, so I'm not going to actually print it out yet. And we can fix that by coming down here and simply each time we do this, we're going to just run fflush. I'm going to call fflush, with standard out. And what this means is anything you got buffered, just write it all right now. So take all the buffered stuff, flush that buffer out to standard out. And now if we compile it, and if I save it, and if we come down and compile it and we run it, then you notice now that it does actually move the way we would want it to. So we get the progress bar effect that we're looking for. Now, of course, we do see this odd percent character here at the end. That's because we didn't get a new line at the end ever. And so what I'm going to do is come down here and just after we're done with this whole progress bar thing, I'm going to just add a new line. And now we should get what we want, basically a growing progress bar, and then it gives us that new line and we don't get that little percent sign there at the end. Okay, so now we have a working progress bar, and this one actually seems to work pretty good. It grows steadily over time and it seems accurate, and that's because we aren't really doing anything real with it yet. Okay, so now at this point, we're going to change up our example a bit and make it more interesting. Now, what I would like to do here, there's a bunch of things we could do, but what I'm going to do is we're going to do a bunch of downloads. Okay, so it's similar to what a lot of installer programs do. They have a bunch of different packages they're going to download and install. And in this example, I'm not really going to install anything, but we are going to download some stuff. So let's take our program right here. And what I'm going to do here is just drop in a bunch of URLs. Okay, there's nothing fancy about this. It's just an array of character pointers, and I've got a bunch of URLs. These are just arbitrary URLs, downloading things of different sizes, mostly images, videos, and there's one CD image of, it's an ISO for Debian. Okay, so that one's gonna be pretty big. We're gonna come back to that. Now, it doesn't really matter. You could replace this with whatever URLs you wanted to download. And then down here, I simply just have my number of URLs, which is going to be the size of my whole array divided by the elements. So this just basically allows me to not have a constant up here that defines my number of URLs. I can just basically add as many URLs to this as I want, and this num URLs variable will be appropriately set. Okay, now what I want to do is actually make a function that's going to download a URL, okay? Because that's what we really want to do here. So what I'm going to do is come up here and let's return a bool, just maybe in case there's failures, we can return an error. And let's pass in one argument, which is going to be our URL. It's going to be a character pointer. Okay, now I'm going to use libcurl for this. I did a previous video on libcurl. It's just a library that I find really useful for quick and simple networking without a lot of socket calls. So I'm going to use it here. If you haven't seen this and you want to check it out, I'll put a link down in the description to the previous video in case you missed it. So for this function right now, we're going to take an argument, and I'm actually going to pass in a second argument here. It's going to be a struct, and let's actually go up here and we're going to create this struct really quick before I forget. Now, the reason for this is that eventually during our downloads, I'm going to want to update some things. I'm going to want to keep track of information, and I don't want to use global variables. So I'm going to make a struct, and we're going to call it status info. And for right now, all I'm going to have in here is a number of bytes. Okay, so I'm going to use this so that I can pass this into different functions and I can keep track of how many bytes we've downloaded. So that'll come in later on. So then down here in my download struct, I'm also going to pass in a status info pointer. Yeah, so this basically allows me to pass in some of this counter information and allows me to update it in this download URL function. Okay, now aside from this, things are really going to be easy. We're just going to say we're going to create a handle to a curl object and call curl easy init. That starts things up. At the end, we're going to use curl easy cleanup. Pass in our handle. Okay, so this is basically our initialization and our setup. And then throughout, let's just say like, okay, so if we were not able to get our handle, well, actually I don't need, let's just return false. Okay, so things basically failed. Down here at the bottom, if everything went well, we're gonna return true. And then really basically anytime we're using curl, we're going to set some options, and then we're actually going to do the download. Okay, so let's start by setting a few of our options. So use set opt, pass in our handle, and the option we want to set, the first one obviously is going to be the curl URL, or sorry, it's curl opt URL, and that's going to be the URL that we passed in. So that's the thing we're actually trying to download, okay? Now, the next one I want to set is my write function, and we're going to need a function for this. Right now I haven't written it yet, so let's say it's like gotData, something like that, okay? And then let's also pass in, because we're passing around this status info, let's also pass in, let's do our write data option. So what this is saying is when I call your gotData function, when you actually get data that you downloaded, I want to pass something in, and we're going to pass in this sinfo pointer, okay? You can pass in anything you want, or really a pointer to anything you want, but in this case, this is what I want to pass in. And then let's add one more in here, and this is really just for convenience. Let's add follow location and set it to 1. What this is going to do is it's going to say, if I pass in a URL that has a redirect, and a lot of those URLs that I picked actually do have redirects. They're redirecting you from one URL to another, and I don't want to be bothered by having to figure out where all the redirects go. So what this says is, if there's a redirect, just follow that redirect and grab whatever's on the other side. Okay, now let's come down here and actually do the download. So what's going to happen? Let's see, curl code. This is going to look just like I did in my previous video, but we're going to have a result value. It's going to tell us if it succeeded, and then we're going to perform the operation. Pass in our handle. So this is going to take all those options that we set up and actually use them to do a download. And then if our result is not equal to curl OK, then we're going to return false. Okay, actually, let's do a little cleanup here. So let's make sure we clean up curl as well right here. And then if we're done, then we just clean up and we're done. Okay, so actually, since we're not doing anything really with it, let's just say, let's trim this down a little bit and say curl easy cleanup, because we're always going to do that. And then we're going to say return result equals curl OK. Okay. So normally if we were actually doing something with the data, maybe this is where we would do it. Right now, we're just downloading it. We're saying do your thing. And then when we're done, we're going to return true or false. Okay, so this is going to work. We have a few things we need to do, like this gotData function doesn't exist. So let's come up here and write that. So let's return a size t. That's what these curl functions look like. Call it gotData. And we're going to pass in a buffer. This is going to actually have the data that we are receiving. And it's going to have a couple of sizes. The size of our items, it's going to have another, which is our num items. So the number of items that we actually retrieved. Typically, this is going to be, the number of items is going to be the number of bytes, and the item size is going to be 1. But it's not guaranteed to be that way, so we need both of them. Now, we're also going to pass in a void pointer, which is, we'll call this st_info. This is my status info, the stuff that I passed in down here in this write data argument, right? So I pass in sinfo. That's going to show up right here in this pointer. Now it is void pointer. I may actually want to use it. We'll do that later. But for now, let's just say, because I'm going to eventually want to use this. So let's call this status, and we'll set that equal to st_info. Okay. So that's just telling this function, hey, I want a pointer that I can actually use to reference whatever is inside, but I'm not going to do anything with it right now. So let's just return item size times the num items. Now this just tells curl that I processed the data. Like I actually did receive that many bytes, and it tells it go ahead and keep getting more data. And there's a lot more we're going to do in this function, except for right now, all I want to do is to add, we're going to basically just keep track of how many bytes we've received. So what I'm going to do, let me change this up actually just a little bit and say size t. I'll just call this bytes so I don't get confused. And let's just copy this, or well, cut it, and we'll grab that. We'll return bytes here. But before we do that, we're going to also say status total bytes plus equals bytes. Okay, so this is going to add to the number of bytes we've received so far. So that's going to keep track of how many bytes we've downloaded. It's going to come in handy. Okay, so now let's go down and update things in main. So if we come down here, we're going to create a status info struct, call it sinfo, call it whatever we want, and sinfo.total bytes, we're going to start as 0 because we haven't downloaded anything. Okay, so we've created this, we've set things up. Now let's change things up a little bit and let's change up this loop down here and change our bar. So we'll start it out as 0, okay? And then in my loop every time, now instead of going from 0 to 100, I'm going to go up to num URLs. So now we're just going to go through each URL and we want to actually download them. So what I'm going to do is download URL. We're going to pass in the appropriate URL, the one that the ith URL, and then I'm going to pass in sinfo. Okay, so I'm basically just saying, hey, this status info that I created, give it a pointer, update that with the status information that you get. Okay. And then down here, we need to update our bar. If we do this, we're just going to get like 0%, 1%, 2%. That's not what we want. Also, let's just delete this usleep down here. We don't need it anymore. But yeah, so we need to update this. We need to update the bar now so it actually takes into account the progress on what we're working on. So like, let's start with a really just kind of silly, almost stupid approach. But what we're going to do is let's just start by saying, okay, let's take I plus 1. We're going to multiply it by 100. We're just going to get the percentage of the URLs that we have in our list, how many of those we've downloaded. We're going to divide this by num URLs. All right, so in this case, basically, like when we've done half the URLs, we're going to say 50%, right? Simple enough. And at this point, I think we should be in a position where we can compile our code. Oh, I did forget something. Yes, I forgot in my makefile to go in here and actually link with libcurl. So let's take care of that. That should take care of us. Okay, so now we can compile it and we can run it. And basically what you're gonna see now is it jumps up pretty quick, 20, 40% as it finishes. And then we get to this 60% done and we're just gonna hang out. Right, we're gonna sit here for a long time because we have a really big download in here. You know, our Debian image is taking up a lot of bytes. In fact, let's just cancel this and let's jump in and try to make this a little easier. One thing I'm gonna do is we've already come in here where we're updating. So instead, maybe we could, we have this total bytes. So maybe in my upload or update bar, let's also pass in a status info here. So we'll pass in our status here, and I'm going to do one more thing. I'm gonna say, let's just print out an integer, and it's gonna be our number of bytes. And this will at least just like give us an idea of where we're at and how far we've gone, and we'll pass in our total bytes. Okay, so again, oh, what did I mess up? Oh, I forgot to change how I call it down below. So now we have to pass in status info there, and we'll do the same thing here. Okay, so now we should be okay. Compile it and run it. And so again, 20%, and you can see like we're getting a bunch of bytes. So one problem we have with this is that we're currently only updating the progress bar when a download completes. So that's annoying. The whole point of a progress bar, or at least one of the main points, is to give us hope for the future, to tell us that our program is still working, that it hasn't died, you know, don't kill it yet. And so this progress bar isn't doing that very well. Basically, I don't know if I'm making any progress at all. It just sits there and like gets stuck at 60% for a long time. So the other problem in here is that we're currently treating all of our downloads the same, right? So like we think we're 60% of the way done. We're nowhere close to 60% of the way done. And what's gonna happen once it finishes this download is it's just gonna zoom to the end. It's gonna like sit at 60 for a long time, and then all of a sudden we're gonna be at 100 and it's gonna be finished. And we've all seen stuff like that. Like this download's gonna take 1 hour and then it ends up being 10 minutes or the other way around, right? So let's see if we can tweak this, make a few minor improvements, and see if we can fix these issues or at least make things a little bit better. Okay, so what I'm gonna do is, the first thing I'm gonna do is not update the bar in here. What I wanna do is to update the bar more often. So we're gonna update the bar every time we get new data. Okay, so that should keep things updating while we wait, even if we run into a really big download. Okay, so we've already passed in our status info struct to the update bar function, made sure we took care of that. And we already up here in update bar, we're already printing out the number of bytes. Now, I actually don't like how many it's showing in there. So let's change this to MB, and I'm gonna just divide this by 1,000,000. Okay, so now it's just gonna show the number of megabytes. That seems a little nicer to me. Anyway, the whole point is that when I print out the bar, at this point now, I'm printing out the number of bytes so far, the number of megabytes so far. And so now anytime we get new data and this gets updated, let's update this. So what I want to do here is down in gotData, we got new data. What I'd like to do is to update the bar. So I'd like to call update status bar here and pass in some % done value, right? That's what we do. We pass in a % done. The problem is I have no idea how many bytes to expect. And also, while I'm bemoaning the fact that I don't know how many bytes to expect, let's also add my status. That's going to get passed in. So now I could solve this in a few different ways. I could do a head-only request for each URL and get the download sizes, and that might work. Web servers will often send you content length in the HTTP headers. Occasionally, though, that information may not be available in some cases. So even if it is available, this is gonna slow me down. I'm gonna make a bunch of extra connections. I'm gonna do extra work just so I know how much I'm downloading. So you could do that. You could totally do that. And maybe if you're interested, we could do that in a future video. But today I'm not going to do that. Instead, I'm just going to make some guesses, maybe educated guesses, maybe not, and we'll just update those guesses as we go along, okay? So I can tell you up front, it's not gonna be perfect. Our predictions are gonna be wildly inaccurate because all we have to go on is what we've seen in the past. But let's start by adding a few things to our status struct, and I'll come down here and fix this in a bit. So the first thing I wanna do is come down here and we're going to add a total expected member, okay? So this is gonna tell us how many bytes we think we're getting. And let's also add a double in here. This is gonna be a prediction. It's gonna be the expected bytes per URL that I expect. So for every download that I get, there's a certain number of bytes that I expect to get, and this is going to be a prediction here. And then let's also make another one, which is going to give me my current bytes. This is going to be like the number of bytes in the current download. That's going to be important to keep track of. And then also, because we're trying to figure out the status, because we're trying to figure out how far we've come, we're also going to need a URL so far variable. Okay, so that's going to keep track of how many of our downloads we've done so far. And let's add one more while we're at it and keep track of our number of URLs. So let's call this total URLs. Okay, so now keep in mind, there are a lot of different ways I could do this. Some might be more accurate than this one. So if you think you have an improvement, by all means, make sure to mention it down in the comments. I'd love to see what you come up with. This is just what I came up with in a hurry. Now, we also need to do some prediction, okay? So especially we're predicting how big future downloads are going to be. There are a lot of different ways to do prediction. Today, I'm just going to use a simple exponentially weighted moving average, not because it's the most accurate predictor out there, but because it's simple. I don't want to write a lot of code and it's fast, but mostly because I don't want to write a lot of code. Okay, so for this to work, we need a weight. Anyone that's familiar with exponentially weighted moving averages know that you need a weight. I call this predict. I need to spell predict weight. We'll set that to be 0.4. Sometimes you may have seen this called alpha. Okay, so it's your alpha value. Anyway, it's the weight. It's basically how much we're going to predict based on the last thing, the most recent thing we just saw. Okay, so now let's make our function. It's going to return a double, and we're going to predict the next value based on two things. And that's going to, the first thing we're going to predict based on is the last prediction. And we're also going to look at the actual number of bytes that we downloaded. Okay, so we're gonna get what we predicted was gonna happen, what actually happened, and we're gonna combine these using our weight. So really all we're going to do is return, and what we're gonna return is the last prediction, and I'm gonna multiply that by 1 minus our predict weight, and then we're gonna add to that, we're gonna add our actual, so the thing that we just saw multiplied by our predict weight. Okay, so what this is going to do is it's basically going to just take these two things and weight one a certain way and the other just the rest. So I'll let you play around with the math a bit, but you'll notice that basically if last prediction and actual are the same, then the prediction is not going to change, right? It doesn't matter what the weights are. And if I make the weight bigger, let's say I'm all the way up to 1, then we're going to predict more based on the last measurement or the new data that we just received. And if we make it lower, then we're going to predict more based on our older predictions, basically what we've predicted in the past. And so that's how this predictor is going to work. Very simple, nothing fancy. You could definitely get fancier with this. Okay, so now let's jump down into our gotData function and see how we could use it. Now here we need to be a little more careful about how we do things. The first thing I'm going to do is I need to update the current bytes. Okay, so already you're updating the number of total bytes. So let's come down and add this. And let's set current bytes. Let's also add bytes to that. So then we need to make a prediction. Once we've increased the number of bytes and current bytes and total bytes, now we need to make a prediction of how many we have left or how much work we have left. And I'm going to break this down into pieces so that it's hopefully not too confusing. Okay, so the first thing I'm going to do is let's create a new temporary variable called URLs left. Like I said, I could probably put this all on one line, but I'm trying to make this as intuitive as I can. So what we're going to do here is we're going to take our total URLs minus our URLs so far. Okay, so this is pretty obvious, but I just want to keep it conceptually straightforward. And then next, I want to estimate the size of the current download. Okay, so let's make another one. We're going to estimate the current download. And I'm going to start out by just setting that equal to this expected bytes per URL. So this is our global, it's not global. This is our prediction in our status information of what we think the average number of bytes per URL is. Okay, now, of course, it could be wrong. So let's come in here and say, what happens if our number of current bytes is actually greater than our expected bytes per URL? If that's the case, then we know our prediction's wrong. So for now, let's just say, let's estimate our current to be something else. So maybe we can say it's current bytes, and let's be pessimistic here and say we got a bit left to go. We could assume we're almost there, but I'm gonna say we're like 3/4 of the way done. Okay, so this means if we ever are past, we're in uncharted territory, we've got a big download, we're going to be a little pessimistic and assume that it's got a ways to go. Now, based on this estimate, I want to guess what the next prediction is going to be. Okay, so we'll use our predictor here, and let's say guess next prediction here, and we're going to use our predict next function, and we're just going to pass in our status, and let's pass in our expected bytes per URL. Okay, so that's basically our old prediction, and then let's pass in our estimated current. Okay, so what we think we've got ahead of us. Again, this is just a guess. And this is the prediction that we're going to use to forecast the rest of our URLs, right? Because we're trying to update this global progress bar. And so now that we have our next guess-based prediction here, now let's try to estimate the total bytes for all the downloads. Okay, so this is really what we've been getting at all along, but I need to spell estimated total. Okay, this is going to be something like, well, let's start with our total bytes. We know how many we've actually downloaded total so far, right? And then we need to add what we think we have left in the current download. So that's going to be estimate current, right? And we're going to subtract off the current bytes from the current download. Some of those total bytes are part of the current download. We have the estimated size of our current download. So this is how much we have left in the current one. And then what we're going to do is come in here and say URLs left -1. So basically how many after this one we have times guess next prediction. Okay, so this is an updated estimate of how long we think our future URLs are going to take based on our new prediction that we've just made. Okay, so I know this is kind of a gnarly line of code, but hopefully the math is pretty straightforward. Okay, now once we have the estimated total, now we just come in here and get our percent done. I think no underscore down below. And we're gonna take our total bytes, multiply it by 100 and divide it by our estimated total. So now it's really simple. We're just coming up with the percent, and then we're going to pass that into our updated bar function. Okay, so now the last thing we need to do to make this actually work is we're going to jump back down into main, and we need to update a few things. One, we need to come in here and set URLs so far to be 0. So we're going to initialize that. Our total URLs are going to be set to num URLs. That's how many URLs we need to download. And then we need to start with an initial prediction. Now for this, I could pick whatever I wanted. Let's be a little bit pessimistic, and I'm gonna let's do 100 megs. Okay, whatever I pick, if I pick something too small, then my progress bar is gonna grow really fast and then slow way down. If I start too big, then it's gonna be really pessimistic until it gets a couple of downloads under its belt, and then it's going to start to calibrate itself and get a little bit better. So let's start on the big side, and then we'll just let it adjust as it goes and see what happens. But of course, as always, feel free to tune this as needed for your individual needs, right? Okay, so now let's come down into our for loop and see if we can make some changes. The first is before each download, I need to set current bytes, reset it back to 0. And then of course, we don't need to update our bar down here because we're doing it every step of the way, every time we get some data, but we do need to update our number of URLs so far after each of our downloads. And let's also update our prediction each time through. I was making some temporary predictions, but we now need to basically, once we're done and we know how many bytes we actually got, let's use our predictor to predict what things are going to be like from now on, now that we have actual information. And so let's start with our old prediction and the current bytes, basically how many we got from the current download. Okay, so this is going to update our prediction. So this should work, assuming I haven't made any mistakes. Of course, there's always possibilities, so we never know how this is actually going to go, but let's try to run it. So here you notice that it is updating. Okay, you notice it's still working, we're moving along. It started out kind of slow because it was very pessimistic, but now things are moving a lot faster. You notice it's adjusting itself. At this point, 35 megabytes in, we're definitely on our big download. So you notice how it went forward and then it came back a little because it's like, whoa, this one's really big. And so it keeps adjusting, and as it goes, it's probably going to keep adjusting back a little bit. Although it's interesting, it's making forward progress and also discovering that it's got a really big file on its hands all at the same time. And this is something that you've come to expect from progress bars in your life. And hopefully at this point, you're starting to understand why. I mean, obviously people want their progress bars to be as accurate as possible, but as a developer, you're up against two key truths. The first is you never know how long things are going to take to complete. In this case, the uncertainty comes from the unknown download size. We just don't know how big our downloads are. And even if we knew how big our downloads were going to be, the server could slow down due to a lot of traffic, or traffic on my local network or on the internet as a whole could increase, or my computer could start rendering a video or something that takes all my processor time, and that could slow things down. Whatever the reason, the point is that there are a lot of reasons that I might think that I'm almost done, and then things could slow way down and they could speed back up again. And so getting this right is actually really hard in general. Now, the second truth is that we can rarely afford to spend a lot of time on making great progress bars. The point of a progress bar in most real software is to give you some comfort that the program is still working. I mentioned that before. We wouldn't complain, of course, if our progress bar was more accurate, but it's probably not going to make the difference between whether or not I buy your software or whether I don't. And getting really fancy with improving prediction is probably also going to slow things down. It's going to take up processor speed. It may take up network bandwidth. And so for most of us, in most of our applications, the progress bar becomes an exercise in good enough. It needs to keep moving, and let's try not to make it too bad, but it's rarely worth going to great lengths to make it perfect. So I hope that helps you put a progress bar in your next program. And I also hope in the future, from now on, whenever you see a progress bar that's not all that accurate, hopefully you'll give it a knowing look and be like, that makes sense. I get you. Keep working, little program. You're going to make it. Thanks for being here. I hope you enjoyed it. Like the video, subscribe if you don't want to miss the next one. And until then, I'll see you later.